And now for this lesson, we've got some inverse cosine problems to work through. Remember, when we're using the inverse cosine, we're looking for the angle. So this first question right here says, in right triangle ABC, if cosine of A equals 2 over 7, calculate the inverse cosine of 2 over 7 to determine the measure of angle A. So in my calculator, that's pretty easy. To get our inverse cosine, we'll just do second cosine. And, oh, we don't need another parentheses there. It's 2 over 7, so 2 over 7. You can do 2 divided by 7. If you're using one of the school calculators, you can do the alpha y equals enter and get the fraction. Either way, you're going to get the same answer of 73 degrees. Number 2 says determine the ratio for the cosine of B and then use the inverse cosine of the cosine of B to calculate the measure of angle B. So the ratio for the cosine of B, what is adjacent to angle B? That would be this side, which is 16, over my hypotenuse. In this triangle, it happens to be 18. Now I'm going to do the inverse cosine to find the measure of angle B. And so again, we're just going to do second cosine, and our fraction is 16 over 18. And that gives me an angle of 27 degrees. So now in number 3, it doesn't actually have us set it up first. It just says calculate the measure of angle B. If you're really good and you've got this figured out in your head, you can just stick it in your calculator. But let's go ahead and set up our cosine of B. So the cosine of B is the adjacent, which is 5, over my hypotenuse, which is 8. Now, again, in my calculator, what I'm going to do the inverse cosine of 5 over 8, which gives me an angle of 51 degrees. And then our last problem on the next page, it is a word problem. And in this word problem, it says, a typical cable-stayed bridge is a continuous girder with one or more towers erected above piers in the middle of the span. From these towers, cables stretch down diagonally, usually to both sides, and support the girder. Tension and compression are calculated into the design of this type of suspension bridge. So if you've ever seen pictures of the Golden Gate Bridge in San Francisco, that is an example of a suspension bridge. One cable is 95 feet. The span on the deck of the bridge from that cable to the girder is 80. I think this isn't supposed to have it in here, just 80 feet. Calculate the angle formed by the deck and the cable. So this is kind of hard to see, but this long side, the hypotenuse, is 95. The short side is 80, and then we're looking for this angle in the middle, so we would definitely use cosine. So cosine of x equals our adjacent, in this case it's going to be 80, over our hypotenuse, which is 95. So angle x is going to equal, inverse cosine of 80 over 95, which gives me an angle of 33 degrees.